This video is just a review again of 3.1 homework assignment 31. On the previous page you had problem number 4 remaining, and I want to go over it now because it covers all of the rules. You remember you will not be graphing polynomials, but you must take the equation and match it to an existing graph. Problem number 4a, y equals 12x squared minus x cubed minus x. First thing I notice is that there's no number at the end, so my y-intercept is 0, 0. So the first thing I'm going to do is look at 6 graphs. Number 1 does not go through 0, 0. Number 2, no 0, 0. Number 3, no 0, 0. Number 4 does, number 5 does, and number 6 does. So number 4a will either be 4, 5, or 6 graphs. Keep that in mind. The leading term is not in order. The leading term is negative x cubed. Negative says the right end will be down, such as this. The 3 being odd for the exponent tells me that the other end will be opposite. So if the right end must be down, the left end is up. So this is the ending of the graph. Now if you'll look, number 4, both ends are up. That can't be it. Number 6, the right end is up. Can't be that. Number 5, the left end is up. The right end is down. So we would match graph number 5 with problem A. Alright, we'll look at 4b. Y-intercept, no numbers at the end, 0, 0. Now we've already been through this. It can't be 1, 2, or 3. So again, 4, 5, and 6. The leading term, it is in order this time, is x to the 6th power. Positive says that the right end is up, such as you see on my little sketch, and many times I'll do a sketch. 6 is even, so the other end, the left end, is doing the same thing. So both endings are up. Now let's look at 4, 5, and 6. 5 is up and down, not it. 6 is down and up, not it. If you look at 4, up and up. So equation B goes with graph number 4. Equation C, y equals x to the 5th minus 5x cubed plus 4x. No numbers at the end, so 0, 0. The leading term is x to the 5th. Plus says the right end is up here. The 5 being odd says the other end has to be down. So I'm looking from down to up. Okay, remember 4, 5, or 6. These are both up, can't be. This is up and then down, can't be. I want one that's down and then up. So that would be equation C, graph number 6. Now pay very close attention to D. We have to go through every rule we have here. The y-intercept is 0, 20. Now if you remember, we've already used 4, 5, and 6. They were 0, 0. What you have to understand is that there are no numbers here, but that could be a positive 20. That could be a positive 20. That could be a positive 20. So A, B, or graph 1, 2, or 3 could be it. The leading term is negative x to the 5th. Now the negative says that it ends down on the right. 5 odd says that the other end would be up, so it's going to go from an up to a down position. Alright, look at 1. Up to down. That's possible. 2, down to up. Not even possible. Number 3, up to down. So I'm looking now, I'm narrowing my attentions to graph 1 and graph 3. Okay, how do we break the tie? Here's one way. If you look at the leading term and its exponent 5, that tells me that I can have one less, that would be 4 maximum minimums. So let's think about that. One less. Maximum minimums. Now these are the little humps that you see in a graph, highs and lows. If you'll look at graph 3, start counting with me from a low to a high. That's 1, 2, 3, 4, 5, 6. Maximum and minimums, highs and lows. It can't have but 4. It cannot be that many. Now let's count the first one. Here's a low 1, here's a high 2, a low 3, and a high 4. that's the number of max minimums. Now there's also another rule that says because of the 5, I could have up to 5 zeros. It doesn't say I have to have, but if you'll look at these x-intercepts, I only have 1, which is a good possibility. Now this is just a review that entails all of the rules that we've had thus far.